In this lesson, I would cover transactions on data. This is a very important topic from system design perspective. So what are transactions? Any application that is backed by a database can run into many issues. So the machine hosting the database might crash, or there could be some power outage, or the network itself might go down. So consider the case where you have one database that has an e-commerce website that has 4 or 5 main tables in a database, suppose products and orders and customers, and a customer is buying something, you're inserting records in the database, suddenly the network goes down. So half of the tables are filled with good data, and while the other tables do not have good data in them. So the data is inconsistent. This state is quite common, and to fix this, the database came up with the concept of transactions. So for an application to be stable, it must handle these scenarios, else the data might get corrupted or other failures might occur. As I said, database came up with the technique of transactions. So what is a transaction? A transaction is a way to group several read and write operations into a single logical unit. So basically it is an all or none operation. So if you are updating 4 or 5 tables in one shot, even if one record doesn't get updated in one table, the entire transaction fails. The entire process is rolled back. So none of the tables are updated. This makes the life of a programmer very easy, because before, transactions were not there. For each and every table that has to be updated, the programmer would have to write the code himself to check whether the table was updated correctly or not. Then he would move to the next table. This is something what we do in eventual consistency when you need to update a lot of tables in a distributed database. I would come to it later. But from a transaction perspective on a database, the database out of the box provide this feature which you can directly use for all or none kind of operations. So transactions are very similar to locking a set of operations before the entire process passes or fails. As you are locking a set of operations, it does slow down the performance. So if there are too many transactions on a database, the performance is going to take a hit. So to speed up the process of of operation of a website, we give up some transaction control, and due to this, if you read the last line, some databases came up with eventual consistencies, the NoSQL databases. That is needed for scalability, because distributed joins are not supported in relational DBs. And so what does a transaction provide? Our transaction provides a functionality known as ACID: atomicity, consistency, isolation, durability. So consistency is basically the data is left in a consistent state. It is not corrupted, and the data is basically, if your transaction is pulling money from one account A and putting money in another account B, the transaction must leave both the databases in a consistent state. Right, so this is basically consistency. The data is always in good state. Isolation: multiple transactions do not affect the work of each other. So this prevents conditions like race conditions. So if multiple transactions are running, they can corrupt the occurrence of of some calculation. So durability: changes last even after transaction end. Atomicity: it's an all or none operation, right? The first one is atomicity, either everything occurs or none occurs. So let's take an example of a transaction here. Suppose a bank customer is withdrawing say $500 from an account AA to and putting money in an account BB. This simple step involves several small subtasks. So I have shown it in a table below. So what happens in account A? In the first column, you open the account A, then you check the balance of A, and finally you decrease the balance of A by $500. So the new balance of A is the new balance which is less than $500. What happens in account BB? You open account BB and you see the current balance of account BB, then you add $500 to it, and that becomes the new balance of account BB. Now all these steps, if suppose the transfer of the money from AA to BB while it is occurring at that time, the machine AA goes down or the machine BB goes down or the network between them goes down and this doesn't happen, the entire transaction has to fail. Otherwise the money will be withdrawn from account AA, it will not even reach to account BB. Right? So there is money has not reached to BB, but account A has already reduced by 500. That's why we need atomicity, all or none operations in transaction. Handling a transaction is, databases provided out of the box. You can use stored procedures. If entire set of data lies in one relational database for you, you can use stored procedures out of the box and create transactions in them in PL/SQL. Or if you are putting transactions on the middleware layer in your code, you can use tools like Hibernate, object relational mapper tools, and which ship along with transaction managers inbuilt inside them. Or you can use Java Transaction API and use programmatic transactions. You can code the transactions piece or code in Java and use it directly. There is another mechanism by which declarative transactions can also be used in the middleware layer. Basically, you need to provide a set of configurations to run a certain set of code within transactions. And as an example, I have given the framework. Spring Framework uses aspect-oriented programming. So this is for all the Java developers. They can directly use this out of the box if they are using Spring Framework, and they can use the concept of AOP to apply transactions in their code. So transactions are very important if you are building from system design perspective. If you are building an e-commerce store, or you are wherever you are purchasing something, because the stuff is at that point in time when a customer is buying something, it is running in a transaction. It is updating a record in the database. It is inserting a row in the database. At that time, the data should not get corrupted. For read-only data, you do not need transactions as such, because the read-only data is not getting changed at all. Thank you.